Good morning, everybody. I think it's time to start. Thank you very much for making this extraordinary lecture on, relatively early on a Friday morning, but this was the best time where we can arrange it. My name is Sabina Leonelli. I'm the director of the Exeter Center for the Study of the Life Sciences, Egenis, here at the University of Exeter. And it is my great honor and privilege to welcome Stefan Helmreich here with us. He's professor, the Elting E. Morrison Professor of Anthropology at MIT, and really one of the towering figures in science studies and anthropology of science and technology in the world. And I'll say a few words introducing him in a second. First, I wanted to say something about the context for this public lecture. And this is a workshop that we were organizing yesterday and today on called Values at Sea, Science Studies Meets Marine Biology. And of course, many of the people here in the room with us are attendees at this workshop. And this is an attempt to try and bring together the community, which of course is already thriving, of people working in science studies, working on marine biology, people working in history of science, working on marine biology, the very few people in philosophy of science who are working on marine biology, and we're now trying to encourage this, and many illustrious marine scientists themselves to work together and exchange notes and thoughts about how we think about values and more generally the place of marine biology in society and the ways in which the practices of marine biology are developing these days. And of course, in the context of this conference, we really couldn't have a better keynote speaker and public speaker than Stefan Helmreich. I want to first thank, before we go on to introduce him, the funders of this workshop. The main funding has actually come from the Southwest Doctoral Training Partnerships, and this also signals the main person that's been doing really by far the lion's share of the work in putting together this workshop, which is Alice Jones sitting here, who is funded by the partnership, but is being very able towards the end now of his PhD in really bringing together all his resources, and everything is learned here, and also the funding resources to really initiate this and take care of by far most of the organization. I also want to thank the Marie Curie Action of the European Union, which funds the work of Jose Canada, who is the second organizer of the workshop, who also has done a fantastic job in helping through all of this, and right now is actually monitoring our online presence. So hello to everybody who's following us from far away. And of course, the Egenis Center has been co-sponsoring this event, and also the journal History and Philosophy of the Life Sciences has been contributing to this. So thanks to all of those funders, and of course to all the people who have been allowing us to put this together. Now, about Professor Helmreich. Now, I think it was about maybe 1999 when I came across Stefan's first book, which was called Silicon Second Nature, Cultural Artificial Life in a Digital World. This was published in 1998. And for me, it really just opened up my horizons about what could be done with something like science studies. I've been, I was 2 years into my undergraduate degree in STS, actually one of the few places in the world where you can do that as an undergraduate. But that for me was just a fantastic read, because it was about some of the most fascinating science one can think of. And at the same time, it was really bringing together ideas around how we rethink human nature, how we rethink life itself in light of latest developments in technology, but with a critical eye, really thinking about these things not in a hyped manner, but in a very, very well contextualized and very inventive and creative manner with a wonderful, wonderful style of writing. If you haven't read any of Stefan's work, I very strongly recommend that you go and read it, because just hearing about it doesn't quite give you the sense of how wonderful the writing is. And now this was just the first of a collection of books that Stefan wrote, and many, many other works. He's really, as I said, is a towering figure in science studies. He's been having an enormous influence in the field, thank goodness, given all that he's brought to it. And one of the main interests of Stefan for many years has been the ocean, the sea, marine life in his many acceptions. And he also has a very strong interest in the intersections between those set of practices and all those kind of adventurous practices that go under the heading of artificial life or artificial intelligence, data intensive work that of course people in Egenis here have been very, very interested in. So it's a fantastic combination of work for us. The main book, I suppose, that we still have very much in mind when we're thinking about Stefan's work on the Sea, is Alien Ocean Anthropological Voyages in Microbial Seas, which was published in 2009. That won pretty much every prize that could possibly be awarded in our field and some, and beyond our field. And again, is a very, very strongly recommended read. But what's really exciting about today is that Stefan has just finished a book that's about to be published in the fall, which looks at wave science. And what we're getting today is, one glimpse of the book and at least one aspect of the wonderful things that I'm sure we're going to all find in that volume. So without further ado, many thanks, Stefan, for being here, and the floor is yours.
I am green, yes. Thank you, Sabina, so much for that kind invitation. And thank you to Ellis, Jose, and Sabina for inviting me, and all of you for being here. It's a real pleasure. Let's see, does this work the way that I think it works? It does. Okay, here we go. This is the title: Ocean Waves, Ocean Science, Ocean Media. Rising into view from the motorboat that I have hired from Marina del Rey, California on this October 2017 day is the Floating Instrument Platform, a seagoing research vessel operated by the Scripps Institution of Oceanography at the University of California, San Diego. Flip is moored 35 miles off Malibu, positioned in 600-meter deep water, floating at coordinates I was emailed last week, or the previous week, by the platform's chief scientist. It is a singular vessel, offering an off-kilter vantage point on the sea. In its horizontal orientation, Flip can be towed out to sea like an ordinary ocean-going craft. But by flipping 90 degrees into vertical, once it reaches its at-sea destination, it can become an enormous spar buoy, more or less stationary in the wave field, looking like nothing so much as a maritime metal treehouse. With 7/8 of the platform's 108-meter length below the surface and all the instrumentation inside its top 1/8 swiveled on gimbals by 90 degrees, scientists can study ocean dynamics from a platform with only a slow bob. I've secured a berth on Flip to do anthropological fieldwork about oceanographic fieldwork, to join scientists examining the zone where water meets air, where ocean waves broker the exchange of heat, gas, and momentum between sea and sky, shaping weather and climate. I want to know how these researchers do their science at sea, as opposed to on paper, in computer simulations, or in laboratory wave tanks, all of which I write about elsewhere. My first observation is that oceanographers study the waves in the field by seeking to hold their scaffolds of apprehension still. That is an operation that has them flipping frames of reference, moving from being wave-tossed and even seasick to being aloof, pivoting from grid-like mathematical accountings to considerations of their work as a source of wonder, a fund for environmental attunement, and a social process rotating in and out of alignment with the pure and the applied. Flip is a legend in oceanography, a one-of-a-kind wonder, says the Smithsonian. Built in the 1960s, its earliest use was for Cold War research into submarine acoustics, as well as into Pacific storm tracks, key knowledge for mid-century US expansion across that ocean. Flip has been central to making sea space legible to oceanographers, but also the US military. The vessel, though operated by Scripps, is owned by the Navy. And the platform, not technically a ship, since it has no propulsion power of its own, puts me in mind of the lithographs of M.C. Escher, full of sideways doors, swiveling sinks, tables in dual orientations. Having toured Flip on in port on its side in San Diego, I compare my photos of what rooms look like this way rather than that. When I spent my first night on Flip, I realized that my top bunk faces a ceiling that is on sideways days a door. I recall Wittgenstein's storied cartoon duck that becomes a rabbit when one flips one's perception of it, seeing what was in one frame of reference a duck's bill becoming rabbit ears in another. Flip came into service a couple of decades after Scripps' research on wave prediction for World War II, which unfolded at or near beaches, aimed at forecasting waves for Allied amphibious landings on Nazi-held shores like Normandy, an effort led by European immigrant and expatriate oceanographers Walter Munk and Harold Sverdrup. During the Cold War, Scripps scientists turned their attention to the open sea. Flip was built just after the Soviet Union launched Sputnik, which motivated US technoscience to undertake spectacular, often futuristic constructions. In recent years, Flip has become a site for studying how waves break in the open sea, relevant for knowledge about shifting distributions of carbon dioxide, climate change. In what follows, I chronicle my stay on Flip, providing a glimpse of today's seagoing wave science, gesturing along the way to the history of such science from the Cold War on. Contexts of wave research discovery, motivation, and justification have shifted from military to ecological concerns. Ocean waves, I suggest, have also across this trajectory become readable to scientists through conceptual schemes made available by media technologies, including time-stepped aerial photography, visualizations of wavelengths in electronic communications, for example, graphs of the radio spectrum, infrared readings of turbulence. Where am I? And laboratory simulation and more. Scientists apprehend waves through mediations, viewing waves, to adapt terms from media theory, as forces of transmission, as patterns that materialize at interfaces of air and water, of buoys and computer screens, and as mechanisms of inscription, producing traces that can be read, for instance, for evidence of distant storms. Technological and media forms imprint on how ocean waves manifest as objects of knowledge. Nietzsche once observed that our writing instruments are also working on our thoughts, flipping the script on the usual assumed directionality between thinking and inscription. Wave science, to draw on Roland Barthes, is a practice of interpretation in which the reader is no longer a consumer, but a producer of text. My first fieldwork frame of reference, Flip, comes when I leap from my wave-borne boat onto the neck of Flip. I clamber up the craft's ladder and meet the 9 researchers and 5 crew with whom I will spend the next 5 days. They've been here a few weeks. I ask an engineer assistant to the chief scientist to draw me a diagram of the instruments arrayed on the frame of Flip, keyed to their scientist operators. I come across Dave, fresh from his PhD at the University of Miami, standing on a gridded metal walkway studying the waves. And I ask him what he sees. Quote, "Young waves developing, westerlies turning on. It's the afternoon sea breeze. It seems like the swell has died down a little bit, but you can see a longer oscillation coming in from the Pacific Ocean. And the short waves we see here are going to come and mess everything up for people trying to surf. You're seeing white capping a bit. 10 knots is about the cutoff. Nice classic Southern California wave field. This is what we've had every single day, except during the Santa Ana winds," unquote. Dave is in charge of a surface following meteorological mast that he calls FLOP, for Flip's lowest observation point. Tethered to one of the booms, FLOP consists of a pole that has mounted onto it temperature, humidity, and pressure sensors, as well as a motion pack, which Dave tells me measures linear acceleration and rotation from which we can extract wave information. We can directly relate that to wave height and hopefully with some tinkering wave direction. Back inside Flip, he shows me a computer screen translating that data in real time into a scrolling visualization that shows a spectrum of wave energy over the course of the day. Some squiggles represent the unhurried yawing of Flip, a side-to-side wobble with a minute-long period. Dave says that this motion will be digitally removed when he cleans up the data. This is a sign that the mediation offered by Flip requires recalibrations of context. As we watch wave frequencies scroll, I think back to the history of how waves came to be understood as spectral media in the first place. Wave observations before World War II were not yet animated by a sense that waves might be sorted out by frequency into something called a wave spectrum, analogous to a spectrum of light or sound or radio waves. Before such a framework became available, waves were understood largely from gathering of data from wave stations from which observers would report incoming wave heights and period. Sometimes scientists got in the water to measure waves themselves. This is Willard Bascom in the 1940s, the large ruler. His stance fusing a kind of dedication to disinterested accounting with an in the thick of it heroism, one that the historian Naomi Oreskes has argued often crafted mid-century oceanographic objectivity as a mix of masculine detachment and outdoorsy passion. Less in the thick of it time and motion studies at piers and beaches generated side views of waves like this. Confidential. Not anymore. At mid-century, something new came to wave science. Aerial photography, a representation of the sea flipped from looking across the horizon, the seascape, to looking down at the sea as a kind of map of itself. And this permitted a view from above. With sequences of shots lined up to create a stepwise flipbook cinema, such views could foretell futures by turning wave time into wave space. Wave scientists had long known waves were generated by ocean storms, which imparted energy to water and created swells that moved across the sea with definite wavelengths and periods. Rachel Carson, in The Sea Around Us, summarized dominant scientific wisdom around mid-century. Quote, as the waves roll in toward Land's End, that's about 2.5 hours from here, on the westernmost tip of England, they bring the feel of the distant places of the Atlantic. As they approach the rocky tip of Land's End, they pass over a strange instrument lying at the sea bottom. By the fluctuating pressure of their rise and fall, they tell this instrument many things of the distant Atlantic water from which they have come, and their messages are translated by its mechanisms into symbols understandable to the human mind. If you visited this place and talked to the meteorologist in charge, he could tell you the life histories of the waves that are rolling in. He could tell you where the waves were created by the action of wind on water, the strength of the winds that produced them, how fast the storm is moving. Most of the waves, he would tell you, are born in the stormy North Atlantic, unquote. Such waves, it began to be surmised in the 1940s, might be sorted out by their frequency, the inverse of their periods, into a spectrum. The intuition came from communications media that had become part of scientists' everyday life, and from looking at these media through unusual angles. British wave scientists during World War II lit upon the idea that it might be possible to measure the variation of frequency with time of wave records from a Land's End observing station and infer the geographical origins of waves with varied frequencies. 20-minute records of wave pressure taken by undersea gauges would be relayed to a rotating drum. But where a usual wave record might be rendered by a pen zigzagging lines on a rolling cylinder, here researchers turned to a method inspired by sound-tracked film. The director of Group W, oceanographer George Deacon, recalled that colleague Jack Derbyshire, quote, had a friend in the film industry, and we learned that the Walt Disney film Fantasia, which was then a recent success, had the sound part of the film as black and white wavy silhouettes along the side of picture frames. It therefore occurred to us that we could do the same thing. We could use photographic paper, and instead of printing lines, we would have a big block of light which would move about, generating a silhouette. Of the waves. We could then put this on a wheel, and as the wheel spun around, the variations in black and white could be detected by a photocell, unquote. Movies with sound were not the only media to inspire the spectral model. Oceanographer Willard Pearson adapted the spectrum model to wave records from the work of Bell Laboratories statistician John Tukey, who had used it to examine the statistical properties of noise in electronic circuits. Tukey rendered waves as populations, not individuals. Similarly to how sociology at the time was coming to see people. No coincidence then that Tukey later co-authored a review of the statistical underpinnings of the Kinsey report on sexual behavior. In these borrowings, scientists turned to emergent media to understand the medium of the ocean. If water waves had once been the model for sound and electromagnetic waves, here researchers generated analogies back in the other direction. flipping the script, which is a phrase, by the way, from a 1991 hip hop song by Peter Rock and CL Smooth, as indicated here from the OED. So the formalism of the wave spectrum makes ocean waves in the medium of seawater thinkable as media in a communicative sense. As John Durham Peters writes in his book, The Marvelous Clouds, quote, "The old idea that media are environments can be flipped. Environments are also media," unquote. Melody Jew argues in Wild Blue Media that oceanographic phenomena knowable through media, cameras, sonar, scuba, satellite, can themselves be theorized as media, forces that crystallize as well as query conceptions about how information manifests as inscription across interfaces and in regimes of storage and transmission. Wave spectra came into focus during an ocean-spanning project during the summer of 1963, when Scripps oceanographer Walter Munk led Waves Across the Pacific, a project that tracked trains of waves from their origins in Antarctic storms across 10,000 miles of Pacific Ocean toward their arrival on the shores of Alaska. Munk was inspired in part by studies in radio astronomy aimed at using diffraction patterns to locate the source of interstellar radiation. Munk, with 8 other oceanographers, arrayed wave sensors at 6 sites across the Pacific, including one on Flip. A 1967 documentary about the project offers in its publicity text a list of locations. Cape Palliser Light in New Zealand. I feel like I should do this in a kind of film voice. A rugged, storm-battered point with the arrival, where the arrival of the great waves from an Antarctic storm could be expected. Tutuila, one of the volcanic islands of Samoa, 2,100 miles to the northeast. The uninhabited equatorial atoll of Palmyra, 1,600 miles beyond Samoa, only 2 miles wide with no point of land more than 6 feet above sea level. The easily accessible Kewalo Basin in downtown Honolulu, selected for the Central Wave Station and Expedition Headquarters. The islandless North Pacific, where the US Navy's mobile island Flip was stationed at 45 degrees north, 150 degrees west. And the final recording site in Alaskan Beach, the end of the line for the trains of waves. The task was to follow waves as they traveled over a great arc spanning the southern and northern hemisphere, with the hope of using this knowledge to improve wave and weather forecasting. The project required observing stations that could permit scientists to position pressure sensors on a not too deep seafloor, or in the case of Flip, on its stem, just below the surface. Sensors would need to be sensitive enough to measure waves as extensive as a mile long and as squat as a millimeter high. These sensors translated changing water pressure into electrical signals, relayed to spooling computer punch tape. In the documentary film, Waves Across the Pacific, we see scientists unrolling tape records and poking pencils through holes to make dots representing wave heights, producing graphs of the travel of waves. Such graphs permitted scientists to map patterns they hypothesized would become readable to stations later in the chain. The data were sent back to Scripps to be processed. As Munk put it in the film, spectral analysis could reveal how groups of waves traveled. Since waves in the wild are, quote, of all sizes and come from all directions, they are mixed and piled atop one another in lovely confusion, unquote. Translating punch tape into graphs, radioing, phoning, shipping, and more could generate spectra to sort it out. The film shows the deployment of multiple media: tungsten wire, water, magnets, brass cylinders, globes, rulers, typewriters, filing cabinets, paper, pencils, punch tape, tape computers, telephones, all of which underscore the mediations through which waves come to be known. And note that all of the in-the-field oceanographers are men. The women, mostly secretaries, record keepers, some scientists, are on land, a gendered division of labor shaped by oceanography's use of sex-segregated Navy infrastructure and by dominant US institutionalization of gender norms. Taken as a whole, the Waves Across the Pacific project comes to render the Pacific Ocean into a giant transmitter of wave signals. The travel of its swells mimes the relay of information from by scientists from one station to another. This ocean becomes akin to a radio, a wavy medium that stores and sends information about storms. In Waves Across the Pacific, the script had Munk remarked that for this project, quote, the sea itself was our laboratory, unquote. This laboratory was available because, with the exception of New Zealand, most points along the Great Circle had come since World War II to be under American rule, either as territories of the United States, Tutuila on American Samoa and Palmyra, or as states, Hawaii and Alaska. As historians Michael Reedy and Helen Roswadowski argue, quote, knowledge of the ocean was and remains inextricably connected to mid-century geopolitics and the growth of modern science. The expansion of empire enabled scientists to study topics that required the accumulation and subsequent reduction, tabulation, and graphing of large amounts of observational data from all over the globe, unquote. The geopolitical context that made waves across the Pacific possible is left unarticulated in the film. The film's narrator instead paints a picture of the Pacific as a space of nature, with scientists tracking, quote, waves that propagate across the entire Pacific, the largest body of water on our planet, waves that are interrupted only occasionally by the upthrust of a lonely coral atoll, waves that smash endlessly against the rock of high volcanic islands like Samoa, waves which 10 days later die quietly on the beaches of distant coasts, the end of a journey halfway around the world, unquote. But these waves move not just through natural space, but through geopolitical space. The lonely coral atoll of Palmyra was occupied by the US Navy from 1939 to 59, during which time the Navy built a runway and dredged a ship channel, after which the island was used in 1962 as a site from which the Department of Defense observed nuclear tests above nearby Johnson Atoll. The waves that smash endlessly against the rock of high volcanic islands like Samoa meet not just a shore, but also a Marine Corps outpost. And the distant coast of the experiment is in Alaska, which had just in 1959 become a US state. When the script has a scientist casually say about the experiment, quote, we preferred islands we could get to, unquote, it leaves to one side the historical context that made these places available, particularly those to do with hydrocolonial enterprise that saw the United States extend its geopolitical maritime reach. That view had been developed in concert with military networks and at mid-century became entangled with nuclear detonations in the Western Pacific. US nuclear weapons testing enrolled Scripps oceanographers led by Roger Revelle, who wrote that the Navy, quote, wanted to learn about the waves that would be produced by the air and underwater explosions and about the dispersion of radioactive materials in the lagoon and ocean waters, unquote, later declaring, quote, the atomic bomb is a wonderful oceanographic tool, unquote. Back in 1952, the US dropped a hydrogen bomb on Eniwetok Atoll in the Marshall Islands. Walter Munk and Willard Bascom, as it happened, were there, tasked with measuring the resulting waves. You can see them there. If wave predictions for Normandy during a hot war sought to know the near future wavescape, so-called tests in the Western Pacific had the military flipping the script, figuring shock waves as proxies for not yet arrived waves of war. The time imagined by the Navy was the hypothetical time of nuclear combat. For Marshall Islanders, of course, disaster arrived right away, with winds and waters also becoming a time bomb, bringing cancer over the next generations. Waves and wave knowledge, in other words, exist in the wake of history. And I'm inspired to this phrasing by Christina Sharp's In the Wake on Blackness and Being, which presses readers to remember the transverse waves of the wake of Atlantic slave ships. For Sharp, following poet Derek Walcott, the sea is history, and waves, particularly ship-made waves, may be its haunting inscriptions. We can say something resonant about waves in the wake of testing in the Pacific. Marshallese poet Kathy Jetniel-Kijiner brings the atoll's story into the present with a vignette of patients on an island hospital inundated by the waves of sea level rise, quote, a nuclear history threaded into their bloodlines woke to a wild water world, a rushing rapid of salt, unquote. The ocean is a substance that churns together different moments in history with nuclear age released radioactive isotopes of carbon, cesium, strontium, and plutonium still circulating in today's oceans, just one enduring marker of the Cold War. Go back to the 1960s and the making of the Pacific into a lab. The Waves Across the Pacific film offers the ocean not as a site of geopolitics or history, but as a site of wild nature, emphasized through images of field-working oceanographers, white men, often in shorts, wearing no shirts, sometimes sporting tropical bead necklaces. A scene of Monk in American Samoa quote, along the exotic southwestern shore of Tutuila, unquote, shows him aided by shirtless local men placing a sensor underwater. He works with tape records in Ifale, a, quote, house built entirely of coconut palm, an ideal place to work with waves, unquote. And he tells us later in the film, as we see him reading a book on a veranda, quote, data taking became quite routine. My wife and some of the Samoans learned to operate the recording equipment, unquote. Though Monk and other participants in the project had more complex relations on the ground that were captured on camera, and Walter Monk's wife Judith's letters to her parents, written from Tutuila in 1963, are worth a look, the filmmakers drew upon tropes representing Pacific Islanders in Cold War Hollywood films as docile natives, giving viewers scientists and waves with lives, but not local or indigenous people. Flip, meanwhile, at her lonely North Pacific station, is a space of pure technology. The film tells us that, quote, wave measurements aboard Flip were comparable and in some ways better than those on land. Flip floated with negligible drifting, taking wave measurements for 3 hours twice a day, unquote. Flip becomes what Helen Ross-Wadowski and David Van Kuren might call a machine in Neptune's garden. Drawing here on Leo Marx's analysis in The Machine in the Garden, on how American pastoral landscapes have come to enfold and include modern technology. Think of bucolic scenes of railroad trains in the countryside. Flip, as an avatar of science, comes to fit right into wild ocean space, both within and apart from it, at the elemental interface of air and water. But Flip is a weird machine in the garden. Its serious side is doubled by the sideways flippiness of the thing. It awakens in scientists a sense of wonder. Some of this derives from the disorienting but intriguing affirmation that the embodied perspective of humans is conventional, that answering questions always requires a frame of reference, and that can be, under the right circumstances, be shifted. Flip offers an instantiation of a meta-objective standpoint, one in which the relative coordinates of human experience nest within a grid of absolute values in which up and down are orientations, not ontologies. David Valentine, in ethnographic work among space travel enthusiasts, observes that the aspirational space tourists that he knows think relativistically about gravity in zero G, on other planets, and on the hypothetical circular space stations that might produce artificial gravity through the centrifugal force of rotation. Gravity, suspended and reorganized, puts for them its status as a universal, as a ground, into question. On Flip, of course, where gravity never goes away, but just shifts experiential direction, disorientation highlights the limited perceptual tuning of humans, a tuning that can be outsourced to observing instruments that can flip axes without getting confused. Still, the moment of the flip is, for scientists, an interstitial moment of wonder. After a while, some of the people in the science party are feeling sorry for me because I missed the flip. People are eager to share. One declares that the flip was, quote, pretty cool. The actual flipping was holding onto a rail, a little bit like a roller coaster bobbing up and down, unquote. Another remarks that, quote, we were giggling like kids. The momentum when it righted itself, it's like a mixture of excitement and, oh shit, this could be the time that Flip has a catastrophic accident. It became a giant metal treehouse, kind of like the Lost Boys had in Peter Pan, unquote. In The Cow in the Elevator, her Anthropology of Wonder, Tulsi Srinivas reminds us that the OED defines wonder as the emotion excited by the perception of something novel and unexpected. Indeterminate, shifting gravity, observes anthropologist Deborah Battaglia in her reading of astronauts' diaries, is often experienced as a zone of levity, of joking. As if to confirm this analysis, scientists on Flip receive a certificate of flipping, complete with calligraphy suggesting an antique age of sail, something like those tongue-in-cheek documents that sailors still get when they cross the equator. If, as I have suggested, models of ocean waves bear the traces of the media through which they've been measured, imagined, compared, becoming doubles or after images of, say, radio waves, it is when waves break in the open ocean that analogies to other kinds of waves break down. And indeed, when the material capacities of seawater as a holder of heat and as an aerosolizing medium begin to exceed formal physicists' models of waves as mere curvilinear pattern. Understanding the matter of breaking waves is a question that keeps scientists on Flip up at night, because it is a question that they often ask at night, when they do not have to deal with the turbulence caused by sunlight on the water-air interface. The sun for me is noise, Moscow-born, Florida-trained oceanographer Ivan tells me. Working at night, he avers, makes the open ocean feel more like a lab where variables are controlled. And indeed, the flip of the platform from horizontal to vertical makes the vessel not so much immersed in a field as floating above it. I've run into Ivan as he's starting his day at 5 p.m. His instrument on the starboard boom features two mid-wave infrared cameras pointed down at the ocean surface onto an area 1.5 square meters. Onto this patch of sea, Ivan projects beams of infrared laser light, visible light just below the visible spectrum, that he has arranged into grids, points, and lines. He images those lines through two cameras to compose a stereo image, whose feeds he can translate into visibility in his on his laptop in the Flip Science Lab. The lines wriggle on the surface, revealing patterns of turbulence. Infrared light, which reveals heat signatures, lingers for a moment after it hits a surface, leaving slurring traces that track the motion of water. It is as though Ivan's apparatus enacts an ancient Greek theory of vision that has eyes shooting beams out into the world to know or to behold it. The images, which warp like syrup, relay the material otherness of the sea, even as their eeriness emerges from algorithmic data conversions first developed for night vision surveillance. But while these look like otherworldly waves, waves with invisible lives, they are also waves that, known through the thermoception of infrared, are very much of our moment, when tracking the exchange of temperature across the interface of water and air may be key to understanding what media theorist Nicole Starosielski calls the intense thermal volatility of climate change. One of Ivan's colleagues on board, Mark, a French-American postdoc, is also interested in wind-wave interactions. He has stationed cameras that point obliquely at the sea surface below the boom. And nearby, he's positioned a fog generation system, sending water particles dancing in the air above the waves. To take freeze-frame photos of this dance, he has installed a laser beam generator that, through beam manipulation, creates a sheet of green light that slices down through the air and the water, reflecting off of fog particles, permitting him to capture 10 nanosecond cross-section snapshots of waves and to visualize the airflow above them. And here are two sequential images, 0.5 milliseconds apart. They remind me of old flip books, though now operating at insane speed, creating quantities of images feasible because of increasing magnitudes of data storage. Mark also likes these images because they remind him of Hokusai's Great Wave off Kanagawa, a reminder of the thick history of aesthetics convolved into the history of wave representations, which have seen waves enrolled to represent the sublime, the recreational, the traumatic, the disastrous. The waves of wave science can be all of these things too. What is all this research for? It's about making unseen sea territories readable. And as Naomi Oreskes has argued, civil and military motives intertwine, though these flip in and out of focus, oscillating between figure and ground. Scientists have accommodated to the alternately loose and tightly coupled with the Navy funding structure, to the social form of research that may lead to dual-use technology, technology with a quotidian public and military application. Consider the territory across which my flip trip unfolded. When I received instructions about how to get to Flip, I was pointed to a map of the US Navy Sea Range, a field of operations testing that is just adjacent to the space within which Flip, along with a bevy of buoys, another ship, and a plane, would map wave space for a project called Coupled Air Sea Processes and Electromagnetic Ducting Research, or CASPER, as it was shorthanded, which examined how electromagnetic signals travel across the sea surface, and it had key funding, no surprise, from the Office of Naval Research. Though play was never far behind, Casper the Friendly Ghost was a kind of voyage mascot, was on all of the notebook covers for all the scientific data collection record keeping. Kind of crazy. Because Some of the military stuff is not so friendly. So for me, as somebody who grew up as an East Coast transplant in Southern California, who bought into surfing visions of the Pacific as a kind of space of imagination and leisure, this map of a militarized sea still unnerved me, jolting me into a queasy wonder at the mathematically and militarily industrial sublime. This vision of the sea as electromagnetic infrastructure. Casper work, as Donna Haraway would have it, is belly of the beast stuff. Still, many scientists on board do not think of themselves as doing military work. One tells me, quote, "I don't find it relevant where the research is funded by NSF or Office of Naval Research. What I mean by that is that the ONR funds basic research that benefits science. Any basic physics research can have military applications, any basic research actually. In a way, I'm quite thankful that NSF and ONR are funding basic research. I'm more of a pacifist. If people are funding basic research in a nice way and giving scientists freedom to do things, it's a good thing. It's public research, it's not classified, and our results are published," unquote. Another says that although their work is funded by ONR, quote, "What I understand and what I research is pretty far from what can be used offensively. Most of it will be weather and it will be public," unquote. I recall the argument of Chandra Mukherjee's 1989 of Fragile Power, Scientists in the State, that many military-funded civilian scientists have a sense of their work as too complex for immediate application. The structure of feeling this creates, Mukherjee argues, is one in which scientists secure a sense of themselves as objective, not beholden to the instrumental aims of their funding. This subjectification generates disinterestedness as a social resource upon which state spokespeople can then call as an epistemological resource to back up political arguments. So as scientists flip frames of reference between subjective and objective, think again of Wittgenstein's duck and rabbit, of flipping from levity to seriousness, from field to lab, from the mundanity to the excitement of being at sea. And as they do this, I want to think about what they're doing as operating within what I think of as paradigm scripts, modes of thinking that take for granted the possibility of seeing things one way and then another. Flip, built in 1962, the same year Thomas Kuhn's Structure of Scientific Revolutions appeared, does not then offer a real revolution so much as a partial rotation, a machine for making orientations, which, writes Sarah Ahmed, quote, "shape not only how we inhabit space, but how we apprehend this world, how we proceed from here, which affects how what is there appears," unquote. Flipping such scripts can be generative of modes of seeing science and its relation to society. To point this out is not to presume to know or challenge individual scientists' full or most personal motives, which may exceed any neat social analysis. Rather, it is to point to the operation of the shifting of frames of reference within which they, and many of us, find themselves / ourselves. Flipping the paradigm script between pure and applied, for example, can create a sense of scientific time as lagging behind as well as racing ahead of political time. Run forward to the 21st century. Nowadays, wave scientists at Scripps are animated less by military concerns and more by ecological ones. I heard time and again in conversation about people's motivation for entering physical oceanography, a concern with the health of the the marine environment. One young scientist made the connection this way, quote, "Well, the whole thing is the atmosphere and the ocean interacting. They exchange masses, gases. They exchange momentum. Wind blows on the water and creates currents and energy. They create swells and mixing. And all those interactions go through what's happening at the surface. And those dynamics are dictated by waves. And also when waves break, they create bubbles and spray. And you greatly increase the surface area. So if you want to understand how CO2 is exchanged between the atmosphere and the ocean, you need to understand what the waves are doing," unquote. We have moved from the age of the Cold War to the era of global warming, to questions of sea level rise, climate, and pollution, things studied by people at Scripps Center for Climate Change Impacts and Adaptation. Wave scientist Falk Feddersen reports on his work around such matters on the Scripps website. Quote, I study how waves come to the beach, break, and dissipate their energy, as well as how sand moves from the top of the beach all the way out to the many hundreds of yards offshore. With climate change, there's very likely going to be increased storms and wave activity, which is going to act to reconfigure the beach much more strongly than is happening right now, along with sea level rise, unquote. Feddersen is interested in how waves generate heat upon breaking, which has implications for coastal infrastructure, with added interest too in the material effluent in waves, phytoplankton, sewage, oil. Wave breaking becomes a process described not by physics alone, but also by chemistry, biology, and ecology. Scripps scientists now look at waves as avatars of anthropogenic process, even damage. On my last research visit to Scripps in 2019, I met atmospheric chemist Kim Prather, director of the National Science Foundation Center for Aerosol Impacts on Chemistry of the Environment. And she told me that when waves crash, they release telling traces of the bodies of water through which they travel. Sea spray is made largely of particles of sodium chloride. But in areas like where we were then, the coast of California, where the atmosphere is dosed with nitrogen dioxide from car exhaust, a gas that fused with water vapor becomes nitric acid, sea spray often turns up heavily laden with sodium nitrate. Breaking waves therefore contain what Prather calls a chemical signature of human impacts. The wake of industrial and agricultural processes is legible in the wave break. And this is an image from her lab, which also points to ways in which biomaterials get bound up in the physical oceanographic processes that waves enact. So false color image of dinoflagellate bioluminescence intensity in wave breaking. So the wave is not just an object for physicists, right? But it's also an object for marine biologists. And you can learn things from how waves break about, not just about physics, but about chemistry and biochemistry. A break is a broken or disturbed portion on the surface of the water, according to the Oxford English Dictionary, one that brokers an interruption of continuity. So let me torque this break into dialogue with Christina Sharp's work, and then also draw upon the poet Fred Moten's In the Break, an analysis of the aesthetics of interruption, in his book, particularly in the Black radical tradition, from the jazz break to the breaking of language and poetry, in which Moten argues that a break is, quote, a temporal spatial discontinuity that requires of those who experience it a fundamental reorientation. Contemporary wave science, I suggest, operates, especially in the time of climate uncertainty and its unequal social effects, both in the wake and in the break. COVID. So this is like a little coda, COVID coda. When COVID-19 became a matter of concern in the United States, some Scripps scientists were asked by some Southern California communities whether the coronavirus might travel in aerosols spooling off from ocean waves, a question that had been preoccupying beachgoers, surfers, and civic leaders. People from the Aerosol Center, about which I just spoke, took an early cautious stance. Some Southern California surfers got angry, deploying predictably US American of the moment language about liberty and freedom, and accusing those who would restrict surfing of being communists. In the event, the claim was modulated, and soon scientists studying ocean atmospheres like Kim Prather turned their expertise to studying coronavirus transmission more generally. If, as I have argued here, waves and their effects have been apprehended through and taken on the qualities of the media used to understand and model them, from animated film to spectrally sorted radio transmission, here the medium of aerosolized seawater created by wave whitecapping and breaking prepares the way for new inquiries into atmosphere, and also operates as a relay for new inquiries into disease transmission as scientists pose their questions, repose their questions, asking not just about the effects on people of air, water, media, that is surf, but also about the effects of people as themselves air, water, media. So to conclude, in his 2015 Anthropod lecture, Paul Gilroy calls for sea level theory as a remedy for the high altitude theorizing that he's seen lately done by some Anthropocene commentators. who often approach thinking about the world as though they are in outer space. There are, of course, many sea levels, and I've hoped here to offer an accounting of how such levels have been framed and reframed in one tradition of oceanography, one that has made orientation and reorientation central to its operation, to its efforts constantly to flip the script on how ocean science as a cartography of liquid infrastructure operates in the wake and the break of our times. That's it.
Thank you very much, Stefan, for absolutely fantastic lecture. I mean, here we really get the absolute best of what happens when we intertwine conceptual ideas and frameworks coming from very different fields, a really solid historical background, and amazing fieldwork. So we're very happy to take questions from the floor now.